Hello and welcome to Teachopedia. Today's video is about a Python library called Pandas. We use this library when dealing with data. Pandas is built on top of another library called NumPy, which is a Python library, and we use this library when dealing with multidimensional arrays and matrices, and it provides us with large number of mathematical functions as well. So Pandas is built on top of this library. We use pandas for analyzing data, cleaning data, and preparing our data. It provides us with function which we use to read Excel file, to read a CSV file, or to deal with JSON or XML data. So let's get started. First of all, install this library if you haven't installed. So make sure that you run these two commands, and after that import pandas and print its version. After that, we will first explore what is series and then eventually create data frames, which is same as we see data in Excel form or Excel sheet. So panda series are a one-dimensional array that are capable of holding data of any type. So here I have created a list and then embedded that list or array into a series. So if I run this cell, I will get a series in which I have for each index or for each row, you can see there is a value. So at each index we have a certain value. Its index start with 0 and goes on till the length of our array or list. After that, I have created another list and convert it into a NumPy array using np.array, and then we can convert that array into series as we did in previous cell. So here I am creating an array of different numbers. So for each value we have its index. Now we can also specify and define specific index if we want to. So I am passing this array, and now I am for each value assigning its index as well. Make sure that the length of this index and this array matches. So if I run this cell, for each value we have its index in form of object or string. So Sarah, Bob, Alex all have some values. And if we want to analyze and extract values, that what are the values in this series, we can use dot values and use our series name. In this example we have ser3. So if I needed its values, I will just use dot values and I will get all the series values. And now if I want to identify or use indexing to get a certain values in this whole series, I will just use indexing concept and retrieve or extract first two or first three values. In this scenario, I am in the first cell or in the first line, I am extracting the first or second values, and then in the second line I am getting the even number index values, and at the end I am retrieving all the values till index number 3 or excluding 3. So if I just run this command or run this cell, we will get first two values as an output of this first line, and then we will get three values by running this second line, and then the third one or the third line will give us the first three values 0, 1, 2. It will exclude 3 and give us output of first three index and its values. After that, I am accessing its element through again indexing, and I can use index and get its value. If I know the index, I can just specify the index and get its value. In the first one, I am just using one index, and if I need to retrieve more than one values of index, I can specify in two square brackets and define my specify or define indexes and retrieve its value. So after this, we are now creating a new series, which is a population dictionary, and now we are creating a dictionary in which we have a key and value pair. So now for each state or city we have its population, and now we are converting that dictionary into a series. So let's just exclude this and paste this here and run this command, and if I just print this population series, I will get a dictionary, not a dictionary but a series in which we have an index of cities and its population as values. So if I need to extract California population, I can just specify my series and then its key, or if I need to extract population from California till Illinois, I can just specify the indexes and it will give us an output in terms of population with its indexes. So now we are creating another dictionary in which we have an area dictionary, and we are converting that into a series. So now if I just run this, so for each state we have its area defined. Now we have two dictionaries or two series, a population series and an area series, and for each city or each state we have its population as well as its area as well. But these were a one-dimensional array and these are series. Now we want to so there is another, if we just want to convert a numpy array into a series, we can just simply use and convert np.array into pd.series and just pass it as a comment or as a parameter, and we will get a series, and it will convert numpy array into a series as defined here. So now if we want to merge these, for each state we will have its area and its population in one box. So we will be using a 2D dimensional space, so we need to go to 2D space, and for that pandas provide a concept which is called DataFrame. So pandas DataFrame is a two-dimensional labeled data structure, and it's typically used for data analyzing, that provides us with variety of data structures and data manipulation methods that allow to perform complex tasks with just one-liner methods and functions. So in the first cell we are creating a merging or merger of population area, and we will have a state data frame in which for each state we will have its population and area. So a series is a one-dimensional and a pandas is a two-dimensional label data structure, or you can say a data frame is a concept in which we will use multiple series. So we have a series of population, we created a series of areas, and now we are merging them and indexing by state. So for each state we have its population and its area. So this is how you can done it. You can use it pd.dataframe and then pass it your series and embed it into a column name, or you can say key, or whatever you would like to say it. So for each index we have its column, population and areas. So here we are creating a multi-list in which we are creating three different lists, or you can say three different rows, and we will convert that into a data frame, and we will define, like for example we are using pd.dataframe and we are passing pet info as a parameter a multilist, our multilist, and defining its column by name, age, and type. So if we print this out, we will have its index in form of 0, 1, 2, which is by default pandas library define its index in form of numbers. And now we have columns, and for each column we have its name values, age values, and type. So here you can see that how we can convert a multi-list into a data frame. So if we want to index or we want to print a column values, we will just use column name and it will return us all the values in that column. We can also use indexes and it will give the indexes which is used in the data frame. So here I am printing its state indexes, and then if we use columns we will get all the column names which is used in that data frame. Thus the data frame can be thought as a generalization of two-dimensional NumPy array where both rows and column have a generalized index for accessing the data. There are other functions which we use when dealing with data frame like .hat, which will give us the first 5 rows of that data frame, .tail, which will give us the content of last 5 rows, .shape, which will return us a tuple in which we can see that how many rows and how many columns are there. And then we have columns and indexes through which we can identify what are the columns and indexes used in that data frame. So typically the process is we read some data through CSV or through JSON or through text files or through Excel files, and we use these functions to understand what that data is about and what columns and what indexes and what are its shape and what column values it composes of. So moving on, now we are like just printing the states area column values, and now if you will just want to see what indexes and what are its areas, we can just retrieve its value through this. If we want to copy a data frame and create its new copy, we can use .copy function or .copy method through which we can get a copy of that data frame and we can pass it to another variable. So we are now creating a new variable or a new data frame data in which that will be the same contents of that state's data frame, but now we are creating another column by using the existing columns population and area, and now we are creating a new column called density. So it's very simple. We are just passing states, and in square brackets we are defining our column names, and for each column you will get its value by dividing with area as values, and we are embedding that into a density which is a new column. So now we have population, area, and density as column with indexes as states. So now if we want to retrieve how many values or how many areas which has a density of greater than 100, we can just simply pass our density, and in that we can just specify and use logical symbols greater than and pass our value 100. So as you can see, we have New York and Florida with density more than 100. So in this example we are extracting the rows which is true and that the population density is greater than 100. You can use this also, but it will just identify what the indexes, what are the indexes which are true, means which have more greater than 100 density and which have not. So it's just specifying whether it's a false or true, and through true, by seeing true you can understand or interpret that okay, New York and Florida have the density greater than 100. So moving on, we can also specify we can also specify multiple statements, and using AND we can specify, okay, if the density is greater than 100 but the area is less than 15k or 1 lakh 50,000, so just print all the contents, and which are the areas, let me know. So only the New York specify that condition. So through AND statement and through AND operator, we are using two statements and defining two conditions and getting our result. Same goes for OR operator. We can use OR operator and getting our required results. So as I mentioned earlier, we can use copy to actually copy the contents of data frame and convert and save it in another data frame. We can also use .loc, which is an attribute. Okay, we can use the loc attribute, which allows indexing and slicing that always reference that the explicit index. What does that mean is that we can use this to index our data frame and get our required values. So in this scenarios we are giving two things. First, to get all the contents till Illinois area or Illinois state and get only its population. No area, no density, just population. So in just one statement we are defining multiple things through .loc function. So in this example we are slicing on the indices and starting with the first by default and ending in Illinois state, and as well as the column we are defining the population. We can also use ILog, which works the same but use indexes other than keys. So it returns the same thing, but we are here defining that only give us 1 till 3, means 0 1 2 3. So it returns Texas and New York only and its population. So as defined here in this example, we are slicing the data frame from index 0 by default to 3 exclusive. It will not cater 3 and it will just return 0 till 2, and from column we are getting only by default 2, or as defined by you. I am defining just one here, so it returns the first column values. So in this example we are importing a dataset, a built-in dataset of a library called sklearn, and we are using its dataset called load. Using load iris we are importing a dataset called iris dataset, and it has its own data with target names and feature values. Feature target name contains the columns and the target values contain our predicted ones, which we typically use when dealing or when predicting something. So in this example we are just using iris.data and saving that into a data variable and getting the column names through feature names and saving that into a column names. So as you can see, we have now created two different variables. One contains the column names of that dataset and one contains the data. And now we will embed that into a data frame, into a two-dimensional space. So, and before that we are just getting to know our data well. We are just printing some rows, some in between rows, some interval rows, and at the end we are creating a data frame and we are passing our data and then columns. So it will convert that into a data frame which will have 4 columns, and for each column we have its specific values. So to understand better, we have our first image like this of dataset, so it was hard to interpret what values belongs to what column or what feature. We have now a clear image. Okay, we have 4 columns and these are its values. So to print some content of this data frame, we are using .head function to just get to know better what the data looks like. So to get the last rows, that how many rows are exactly in this data set, we can use tail function, and through indexes we can identify, okay, there are around 150 rows in this data set. Describe function will typically get and the statistics and brought the statistics and share the statistics with you in form of mean, standard deviation, the contrail range, 25%, 55%, what are the most maximum values, what are the minimum values in that column. So to understand better about that column, we can just simply use .describe. After that, we have another method called info, which will give us, okay, there are no null values in these 4 columns, what are its type. So it will give you around how many rows, how many columns, what are the data types of that columns. It will give you information like this. We can also use .loc and print the content. We can use the mod to find out, okay, what are the mod values of that data frame, and for each column we can also specify the mean average of that column as well. We can also specify the column name and get its mean. Same goes for another. This is using group by, which is actually grouping on the basis of mean and giving back all the results of that mean results. So to conclude that, we have learned some fundamentals of this pandas libraries, which allow us to execute operations, to store data, to manipulate data, to understand better data. We can also use to handle missing data, which is a part of data exploration. We will cover this later, but this will give you a better understanding of how to use pandas, what are series, what are data frames, what are the some basic functions which we could use when exploring and working with new data. So I hope you found this tutorial useful. That's it for today.